So we're going to start off with the perpendicular bisector theorem. So we've talked about perpendicular bisectors. We should hopefully remember what they are, but we have a perpendicular bisector when you have a segment. Let's say this segment is AB. And a bisector, it might not be a segment, it might be a line, but either way, it cuts that AB segment in half. So this point, that section is congruent to that section. Let's label this point D, and let's say there's a point up here, C. Okay? So we're going to call this DC, and we have AB. And if it's a perpendicular bisector, it's going to intersect, CD will intersect AB at a 90-degree angle. Okay. Now, the perpendicular bisector theorem says this. It says if a point, in our case, we'll say point C, if a point lies on the perpendicular bisector of a segment, if a point lies on the perpendicular bisector of a segment, then that point, so that point C, is equidistant from the endpoints of the segment. And some of us might already know what that word equidistant means, but it just means it's equal distance. So if I have a point C and it's lying on the perpendicular bisector of AB, then that point C is equidistant. It's the same length to each endpoint of the segment. So the distance between A and C is going to be congruent to the distance between C and B, and we can mark it like that. So that's the perpendicular bisector theorem, right? And I want to point out two parts of this theorem. We have a hypothesis if a point lies on the perpendicular bisector of a segment, and then we have our conclusion. So I'm going to point those out. Then that point is equidistant from the endpoints of the segment, all right? And there's a reason why I'm doing that, not just to make a mess. So the next thing we'll look at is the converse, if I can spell converse, but it's the converse of this theorem. So the converse of the perpendicular bisector theorem. Okay, and remember we've done this since the beginning of the year. Converse, well, what does converse mean? It's if I started with if P then Q, the converse just switches those around. If Q, then P. So that's exactly what we're going to do. We're going to switch the hypothesis with the conclusion. So I'm still going to draw the same figure here. So I'm going to start with that same figure. I've got a segment AB. Okay. But instead of starting with a point line on the perpendicular bisector, I'm going to say this. If a point, wow, and I can't spell very well today. If a point is equidistant, if a point is equidistant from the endpoints of a segment, so we're starting with the conclusion of the first one. So if a point is equidistant from the endpoints of a segment, so I'm going to take my point, call that C, and it's equidistant from A, equidistant from B. All right, so those are congruent. Then, now we're going to bring in this hypothesis. Then that point must lie on the perpendicular bisector of the segment. Then that point must lie on the perpendicular bisector of the segment. So if I know a point is equidistant from the endpoints, then this point C, it must lie on the perpendicular bisector of the segment AB. So we're kind of just moving backwards. We're just switching around those hypotheses and the conclusion. So again, the hypothesis from the original theorem is now the conclusion for this one. That point, oops, I don't want that to be orange. I want it to be yellow. That point lies on the perpendicular bisector. And the original conclusion becomes the hypothesis. A point is equidistant from the endpoints of a line segment. And that's going to help us solve some problems in the future. So that's the perpendicular bisector theorem. And the next thing we're going to talk about is the it's the angle bisector theorem. And it's very, very similar. So I'm actually going to shorten all of this writing for the next one. I'll do one that's in writing and one that's kind of written as a symbolic statement. Okay, so we have the angle bisector theorem. So let's draw ourselves an angle bisector. Okay, so I've got an angle. I'm going to call this angle, let's say BAC. Okay, and we're going to draw an angle bisector right here. Okay, and we're going to pick a point on that angle bisector. I'm going to call that point D. So here's this angle bisector theorem. If a point lies on the angle bisector of an angle, then, so D lies on the angle bisector, so that means that this angle has to be congruent to that angle. Then the point is equidistant. So it just means it's equal distance from, it's equidistant from the rays of the angle at 90-degree angles. This is what that looks like, okay? So we have a point, and it means that when you're drawing a segment, you're connecting this point to that ray, it's connecting at a 90-degree angle. So it's not going to connect like that or something like that. It has to connect at a 90-degree angle, okay? And in our picture, you know, our picture isn't measured perfectly, but we're going to denote that this is a 90-degree angle by putting that little, that box to show that, okay? So again, I'm just going to highlight my hypothesis and my conclusion. If a point lies on the bisector of an angle, then the point is equidistant from the rays of the angle at 90-degree angles. Okay. So the converse of this theorem is just going to move backwards, but I'm going to write it a little less formally. Okay. So now we're talking about the converse. So we're just switching around the hypothesis and the conclusion. We're going to switch those around. So the converse of angle bisector theorem. And that's going to look something like this. So I'm still going to start with a picture. And I'll start with an angle. And I'll call this angle A. I'm going to have a point here B, a point here C. And then we'll draw a line here, or a ray there, but I don't know necessarily that this is an angle bisector. It's just a ray that's cutting through that angle, okay? And we're going to go opposite, okay? So and then on that line, we'll put point D, okay? if BD, so let's create a segment, if BD is congruent to CD, okay, and if AB ray is perpendicular to DB or BD, and AC ray is perpendicular to CD segment. Okay, so this is where the point is equidistant from the rays of the angle and it's at 90-degree angles. So we're saying these are equidistant and then these are at right angles. They're 90-degree angles. Okay, if that's all true, then point D lies on the angle bisector, and I'm actually going to shorten that even more. So instead, then AD ray bisects that large angle BAC. Angle BAC. So that's splitting these in half, so that means that angle BAD excuse me, is going to be congruent to that other half, CAD, angle CAD. Okay, so just like we did earlier, instead of using words, we used a lot of symbols. Our hypothesis and our conclusions switch. So if a point lies on the angle bisector, so not that, so this is saying that same thing, then it's equidistant. And that's what this is saying. Okay. So make sure you have all of those in your notes and try to answer some of the questions posted. All right, enjoy the snow. Hopefully we get some.